This section is on multiplying special binomials. So I have some problems written in red, some problems written in blue, and one written in green. So I want you to take a look at them and see if you notice a pattern, see if there's anything that jumps out at you. And we will go on to the next screen and we will see if you can figure out the answer to a couple that look similar to this. So you can go ahead and pause the video and just see what you notice, see what you wonder about, jot a few notes down, and we'll go to the next screen. So before we jump over to the next screen, let's take a look at x plus 3 quantity multiplied by x plus 3. So one of the things you might have noticed is 3 times 3 is 9. You might have noticed that x times x is x squared, but the 6x, where do you think that's coming from? Look at the problem up here and see if you notice where that positive 6x could come from. It is coming from the 3. So if you double 3, you'll get 6. But you're going to be careful because when you get down to the problem in green, there's something else that comes into play. If you take a look at the x plus 4 times x plus 4, you've got 4 times 4 is 16. So if you noticed here that we are squaring 4 times 4, so 4 squared gives you the 16. Your x squared is right here, and if you double your 4, you're going to get your 8x. X minus 5 times x minus 5. Negative 5 times negative 5 is positive 25. If you double negative 5, you will get negative 10x there, and you get your x squared. Last one, negative 10 times negative 10 is your positive 100. Negative 10 squared gives you your negative 20. But let's take a look at the problem down at the bottom. So we have 2x plus 6 times 2x plus 6. So, okay, 6 times 6 is 36. I noticed that up here when I did x times x, I got x squared. So 2x times 2x is 4x squared. But now, where's that 24x coming from? I know before we just did the 6, but if you double 6, you get 12. So how am I getting to 24 from 12? Well, if you look a little closer, 6 times 2 is 12. 12 doubled is 24. Does that work up at the top? Let's go ahead and take a look at the x plus 3. What is the number in front of this x that we don't see? It's a 1. 3 times 1 is 3 doubled. Same thing here. 4 times 1, 4 doubled is 8. Negative 10 times 1 is negative 10, doubled is negative 20. So you have to look at the first term, first coefficient of 2 and multiply it by 6 and then double it to get that 24. So go ahead and see if you can say what these are. X plus 7 times x plus 7. Can you do it without doing the area model? Well, we should know that your x times your x is your x squared. 7 times 7 is 49. Now you have your 7 times 1 is 7. Double it. You get your 14x. Because you're actually doing your 7 times you're doing that whole thing there with the x. X minus 9 times x minus 9. Your first two we know are x squared. Negative 9 times negative 9 is positive 81. Negative 9 times 1x is negative 9x. Double it is negative 18x. Now here's the challenge one. 3x times 3x is 9x squared. 2 times 2 is 4. 3x times 2 is 6x, doubled is 12x. And if you're not comfortable, let's go ahead and prove it. So we have 3x plus 2. Okay, we have 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is another 6x, and 2 times 2 is 4. And there you go. You have 9x squared plus 12x plus 4. Now, I know most of you might be saying, well, I can't see these patterns. I'm going to do the area model, and that's okay. The more you see these, the more you start to recognize them, the easier it's going to be. What we'll be moving into midway through this unit is you'll be given this problem, and you are going to have to break it apart to come up with that. And if you can start to recognize that you have your perfect squares, so if you recognize, oh yeah, that's a perfect square. Square root of 9 is 3. Square root of 4 is 2. And I have the 12. 3 times 2 is 6. Double is 12. It'll help you come up with the factored problem that we'll be doing. Here are some different types of special binomials. Here we have x plus 3 times x minus 3, which is x squared minus 9. We have x minus 5 times x plus 5, which is x squared minus 25. And then we have 2x plus 4 times 2x minus 4, which is 4x squared minus 16. So go ahead and jot down in your spiral, what are some things you notice? What are some things you might be wondering about? Look at some patterns, and I'm going to go to the next screen after we talk about this, and we'll do some practice ones. So you still can do area model here, but we're going to, again, look at these for the special cases, and when we factor, it'll be a lot easier for you. So pause the video, as I'm going to come back, and we will talk about what we see. Okay, so I am going to do this with the area model just to show you something. I'm going to start off with x minus 5 and x plus 5. So hopefully one of the things that you noticed was that negative and a positive, these are opposites. So we have x times x, which gives you x squared. X times negative 5 is negative 5x. 5 times x is positive 5x. And 5 times negative 5 is negative 25. If you combine these, 5x minus 5x it's just 0. And that's why you only have 2 terms. You do not have that middle x term because the negative 5 and the positive 5 will cancel each other out. 3x minus 3x is 0. Here you have 8x and then negative 8x, which will cancel out. And when you take a look at the problems on the next screen, try and see if you can do those without using the area model, but that is a good fallback if you need it. Okay, so here we are, x minus 6x plus 6. So you're going to square this first term. So you're going to have x squared minus 36. So you have negative 6 times 6. Here you have x squared minus 121. 3x times 3x, 9x squared minus 25. Here's 2 practice problems that you can do, and check Google Classroom for the rest that will be assigned for classwork and homework.